Alright, so today we're talking about coordinate conversion. So going from polar to rectangular or rectangular to polar. So polar is what we talked about yesterday with the r and theta, and rectangular is just our normal xy. So first, if we want to go from polar to rectangular, I would use x equals r cosine theta. Okay, so to get x, this is what I would need to do. To get y, I would do r sine theta. And this should make sense because cosine's x, sine's y. Okay, now if I wanted to go from rectangular to polar, okay, I need to use tangent of theta is going to equal y over x. So I have the theta, and then to get theta, so then to get r squared, that's equal to x squared plus y squared. Okay, so we're going to be using those in order to convert, depending on what the question's asking. So first, converting polar to rectangular. Example 1. I'm given 2 comma pi. Okay, if we remember from yesterday, it's r comma theta. And so I want to change it to rectangular, so I'm going to be using these equations right here. So x equals 2, because that's my r, cosine pi. Okay, if I look at the unit circle, if I reference the unit circle, cosine at pi is -1, so my x value is -2. Okay, so then let's look at y. So y is 2 sine pi. So again, use the unit circle. The sine value, the y value at pi is 0, so 2 times 0 is 0. So my rectangular coordinate would be -2, 0. Okay, if we looked at another example, this time I have square root of 3 times pi over 6, or not times, comma pi over 6, so there again, r theta. I'm going to be using those same equations. So x equals root 3, bless me, sorry, cosine pi over 6. Okay, again, I'm going to reference unit circle, so use pi, square root of 3, and at pi over 6, my x value is root 3 over 2. Okay, from here, when I multiply, root 3 times root 3 is root 9, which is 3, and then you put a 1 over that, so 3 over 2. Okay, so then let's look at y. Oops, that should be a sign. I'd have root 3 times the y value at pi over 6 is 1/2. So when I multiply across, I'd get root 3 over 2. So my rectangular coordinate would be 3/2 comma root 3 over 2. Alright, so there's how you would convert from polar to rectangular. Alright, let's look at the opposite direction. So rectangular, so if I'm given the xy and I want to convert it to polar. So -1, 1, this would be my x and y. Okay, I'm going to be using these equations up here. Okay, so to get theta, I'm going to take tangent of theta equal to, and it's y over x, so 1 over -1. So tangent of theta, -1. Okay, so where is tangent -1, basically? So if we look at the unit circle, we would see it's at 3 pi over 4. The reason it's 3 pi over 4 because my y value is square root of 2 over 2, and my x is negative root 2 over 2. So when I divide those, I would get negative 1. Okay? And I also need to look, it could also be in quadrant 4. No, quadrant 4, because your y is negative and your x is positive. So when you divide those, you get a negative 1. But because this value right here is in quadrant 2, my answer needs to be in quadrant 2. Okay, so there's theta. And then to get r, I need to take my x squared and add it to my y squared. So r squared equals 2. Well then, square root, so r equals root 2. So my rectangular coordinate would be root 2, comma, 3 pi over 4. Okay, let's look at another example of one of those. So 0, 2. So again, that's my x and y. So tangent theta equal to y over x. Okay, anytime you have 0 on the bottom, it's undefined. So where is tangent undefined? Okay, so if we look at our unit circle, this is up here. So what is this value? Because that would be where it is. So theta is equal to pi over 2. So then r squared is equal to 0 squared plus 2 squared. So r squared is equal to 4. So r is equal to 2. So my polar coordinate would be 2 comma pi over 2. Alright, so there's how we use those equations. Your assignment for this lesson is A13, page 783, numbers 10 through 26 evens. Please let me know if you have any questions, and good luck.